Hello everyone. In the previous class we have discussed about event based timing control and level sensitive timing control. Today we will discuss the next topic, that is conditional statements. So as the name suggests, the conditional statements. So these are used for taking some decisions. So based on that decision, it will go in a particular way when the condition is true. So the conditional statements are used for making decisions based upon certain conditions. So there's such type of conditions you might have studied it in C programming concepts. So same kind of conditions, that is if else, etc., that we are going to discuss under this topic, conditional statements. So these conditions are going to be used to decide whether or not a statement should be executed. So that means if the condition is true, then the following statement will be executed. Suppose if the condition is false, then that particular statement will not be executed. So here the keywords that are used to make a conditional statement is if and else are used. So there are three types of conditional statements. So the usage of those conditional statements we are going to discuss here. So the type 1 is a conditional statement. Here it's a simple conditional statement with no else statement. So this statement executes or does not execute. So here the first type, if followed by expression. So if is a conditional statement. Here the condition is checked here, that is the whatever the expression that you put in the bracket is evaluated. If it is evaluated to a logic 1, then the true statement will be executed if the condition is true. If suppose that condition is false, then the true statement is not going to be executed here, as there is no else part. So it will and it is the end of the if statement. If condition is true, that expression it is going to be evaluated. If it is logical 1, then condition is true, then the true statement is executed. If that after the evaluation of that expression it becomes a logical 0, then that condition is false. In that case, that statement after the if statement is not going to be executed. The type 2 conditional statement, here it is a little bit modification of the first type, that is one else statement is present here. So either true statement is executed or the false statement is executed. It means in the previous case, if the condition is true, then only the following statement is executed, otherwise no statement is executed. But here in this case, if true condition is there, then a statement will be executed. If there is no true, if it is not a true statement, if it is a false statement, then else part is executed without checking the condition. So observe the syntax here. If expression, same as previous, if that expression is evaluated and if it is true, or if it is 1 or it is a non-zero value, then that true statement is executed. If that condition expression, if it is evaluated to a false value, if it is false, or you will get, if you get a 0 value, after evaluation of that expression, then else part, that is false statement, whatever the statement that is written after the else part is executed. And the third one, that is type 3 conditional statement. So this is a nested if else if statement, that is if else if. So here choice of multiple statements are present, but only one statement, one true statement is executed. Not all the statements are executed. Whichever is the first true statement, that is going to be executed. So see the syntax here. If the condition is checked here, that expression 1 is evaluated. If it is evaluated to true, or if it is a non-zero value, or it is 1, then true statement 1 is executed. If the expression 1 is evaluated to 0, or if it is false, then else if, that is second line, else if the expression 2 is evaluated. Now expression 2 is evaluated. If it is true, or if it is logical 1, or it's a non-zero value, then true statement 2 is executed. If expression 2 is evaluated to a false, or if it is 0, then again next else if part is checked, the condition is checked. Else if expression 3 is evaluated, if it is true, or if it is a non-zero value or a logical 1, then true statement 3 is executed. So if this expression is also evaluated to false, you can add any n number of else if, and finally you can have a default statement, else default statement. If none of the if or else if are executed, then this default statement is executed finally. So this is called as nested if else if statement. Here if you have a more than one true statement in any of these, whatever we have discussed, the three different type of conditional statements, if you have a more than one true statement within a same if or else if block, then that must be written using keyword begin and end to group that to group them so that they belong to that particular block only. If when the expression is evaluated to false, that is 0, or if it is a ambiguous value, that is x, the false statement is executed. Remember this. So you can either use a one single true statement, or if you can have a block of multiple statements within a if or else if block, then a block must be grouped. That's why it is grouped by using the keywords begin and end. If it is a single statement, then you need not to be use grouping, that is begin and end keyword is not necessary. If at all, if you have more than one statement, that is multiple statement in a true state, in any true statements, you can use begin and end for grouping purpose. So same thing is explained here. So here there is a example by using the conditional statement. So type 1 statement example is given, that is if block. So here if not of lock, the condition is checked, the lock is a identifier. So if it is tested for not of lock, then if it is evaluated to true, then buffer is equal to data. This statement is executed. If not of lock is evaluated to false, or if it is a 0, then buffer is equal to data, this statement is not going to execute. Second example, in that case only, if enable is evaluated to logical 1, or if it is true, enable is true, then out is equal to in. Otherwise, if enable is 0, then out is equal to in is not executed. In type 2 statement, if number queued is less than max queue depth. So these two are identifiers. Number queued is less than max queue depth. So the comparison is done between number queued and max queue depth. If it is true, that is number queued is less than max queue depth, then the following true statements are executed. That is data queue is equal to data number queued is equal to number queued plus 1. As there are multiple statements, that is 2 statements are written here, it is grouped by using keyword begin and end. If that number queued is less than max queue depth is false, that means if max queue depth is greater than number queued, then the else part is executed. Else part there is no condition here, that's why that is executed. If the condition is false, that is $display queue full, try again. So this statement is displayed by using the display function. So this is an example for the second type. So this is the example for the third type. Execute statement based on ALU control, that is arithmetic logic unit control signal. So condition is checked. If ALU control is equal to 0, it is not assignment statement, it is a is equal to statement. ALU control, if its value is 0, then y is equal to x plus z is executed. If ALU control is not equal to 0, then else part is checked. Else part, if ALU control is equal to 1, if this is true, then y is equal to x minus z is executed. If this condition is also false, then next else if, that is ALU control is equal to 2 is tested. If it is true, then y is equal to x into z. This statement is executed. If this condition is also false, that is ALU control is not equal to 2, then else part is executed. So else is a default statement here, that is $display invalid ALU control signal. That means ALU control signal, it is neither 0 nor 1, or it is also not 2 also. Other than these 3 values, if you enter, then this display function is executed, that is invalid ALU control signal. Like this, the conditional statements are executed. Next topic is multi-way branching. So whatever the type 3 that we have discussed here, that is nested if else if. So if it is the multi-way branching is the alternative of that one. So there were many alternatives from which one was chosen, that is the type 3. So you have if statement, else if, n number of else if parts are available. If none of them are true, then default statement is executed. So if the nested if else if becomes unwidely if there are too many alternatives. So to achieve the shortcut method, there is one more alternative that is called as a case statement. So we are going to discuss the case statement. It is similar to the nested if else if statement. So here for the case statement, the keyword used is case, CASE, small letters. Then at the end case without any space, ENDCASE. These are the two keywords. along with that, a default, default, default is also a keyword that is used at the last. If none of the case is true, then by a default statement is executed. So we'll see the, so there are three keywords here: case, end case, and default. These are the three keywords used in case statement. So we'll see the syntax for this one. Case, 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 it is a keyword followed by some expression. Expression is written here. Then that expression is evaluated and one by one alternatives are checked. If it matches with the alternative 1, then statement 1 is executed. If it matches with the alternate 2, statement 2 is executed. If it matches with the alternative 3, the statement 3 is executed. So here statement 1, statement 2 or statement 3, you can have multiple statements within this also. If you have multiple statements, that can be grouped with the begin and end keyword. Like this, n number of alternatives you can write here. If none of the alternative matches with that expression, evaluated expression, the default statement, default colon, whatever the statement that you write after that default colon, that will be executed. Finally, end case. So this is how the case statement works. So here each statement 1, statement 2 or default statement can be either it is a single statement or it is a block of multiple statements. So as we have done previously also, if it is a single statement, there is no need of using begin and end, because no need of grouping. If you have a multiple statements within that block, then you must use begin and end. So here the expression is compared to the alternatives in the order they are written. That is, observe here, the expression whatever it is there after the case statement, it is evaluated and it will, that alternative is compared in the order they are written. That is alternative 1, alternative 2, alternative 3, that is like one by one, whatever in the order they are written. For the first alternative that matches, whichever the alternative that matches with that expression, that corresponding statement or block of statements are executed. So if the expression is evaluated and it matches immediately the alternative 1, so that statement 1 or block of statement 1 are executed. If it does not match, it will compare with the second alternative. Then if it matches with the second alternative, then that statement 2 or block of statement 2 are executed. If it matches with the alternative 3, the first one is not matched, second one is not matched, then it will go to the third one. When it matches with the third alternative, it will execute the statement 3 or block of statement 3. If it does not match any of the alternative, then by default the default statement is executed. So placing of multiple default statement in one case statement is not allowed here. Remember here, you can have only one default statement within one case statement. You cannot have multiple default statement. So the case statement can also be nested here. Remember, the case statement also can be nested. So the same thing is, you can observe here in this slide. So this is about case statement. So the example that we have discussed earlier, that is for the type 3 conditional statement, if, else, if. The same example we are going to discuss here for the case statement. So that is execute statements based on ALU control signal. So range 1 down to 0 ALU control. That is ALU control is, it's a vector type 1 down to 0. That means it's a 2-bit. Then you will have some declaration part, some program. Then we'll have a case statement block. So case ALU control. So ALU control is a register type 2-bit value 1 down to 0. Then check for the first alternative. The first alternative is 2 tick D0. That is 2-bit value, decimal value 0. That means if ALU control is 0 0, a decimal 0 is converted to a binary 0. That is 0 0 is the value using 2 bits. If you are giving a input as 0 0 as for the ALU control, then the y is equal to x plus z is executed. Here, as it is only one statement, no need of begin and end. If you have a multiple statement here, then you can use begin and end. As here only one statement is present here, no need of begin and end. If ALU control is not 0 0, then first alternative is checked. It does not match. Then it will go for the second statement. That is ALU control. If your input is 0 1, then it matches with the second statement 2 tick D1. So if it matches, then it executes the statement y is equal to x minus z. If ALU control is also is again not is if it is not a 0 1, then it will check and compare with the third alternative. If your ALU control signal is 1 0, that is a decimal 2, 1 0 is decimal 2, then 2 tick D2, this alternative is checked. When you compare, if it is found true, then y is equal to x into z, this statement is executed. If you have given ALU control other than these three values 0 1 or 2, or that is 0 0 0 1 or 1 0. So if you are not giving the value of ALU control out of the other than these three values, if it is any other value, then the default statement is executed. That is display function invalid ALU control signal. That means the ALU control is, it is neither 0, it is nor 1 or nor 2. Other than these three value you have entered as a ALU control. That's why it will display on a monitor like that invalid ALU control signal. Then finally end case. So the case statement can also act like a many to one multiplexer. So the example for that one we are going to discuss here. Module 4 to 1, the list of signals out I comma I0 comma I1 comma I2 comma I3 comma select signals S1 comma S0. Then port declaration part, as we have discussed this program using other modelings. So the declaration part is also same here. Output out, input I0, I1, I2 and I3 separated by commas, then input signal S1 and S0. So here in the behavioral modeling, the output signal must be declared as a reg. The output signal, whichever is the output signal that in your program, that must be declared as a reg. So reg out is declared. Then always block, always at the rate, check for the event S1 or S0 or I0 or I1 or I2 or I3. So this type of example we have discussed in the previous class, that is event or control. If you have a level sensitive latch, if you have a transition on any one of multiple signals or event can trigger then a block of statement can be executed. So here the always block, there are so many alternatives: S1, S0, I0, I1, I2 or I3. Then the case statement. So here switch based on concatenation of a control signals. Here observe there in a bracket S1 comma S0, it is concatenated using curly brackets S1 comma S0. So if S1 is 0, S0 is 0, that means the value is decimal 0. The binary 00 becomes decimal. In decimal it is 0. So first alternative 2 tick D0. If it matches, if you are entering a S1 and S0 value as 00, then this case, the first case matches 2 tick D0, then output is assigned with value of I0. If your value is not 00 in S1 and S0, if it is 01, then second statement or second alternative 2 tick D1, this is executed because it matches with this. Then out is equal to I1 is executed. If your input signal is 1 0, S1 is 1, S0 is 0, then the third alternative matches, that is 2 tick D2, because the value of S1 is 1, S0 is 0, that means it is 2. That's why this statement out is equal to I2 is executed. If your value of S1 and S0 is 1 1, then 1 1 is nothing but decimal 3. So 2 tick D3, this alternative is executed, that is out equal to I3. If you are not giving all these values 0 0 0 1 1 0 or 1 1 for S1 and S0, then it does not match with any of the alternatives, that is 2 tick D0, D1, D2 or D3, it does not matches. Then the default statement, that is using display function invalid control signal, this statement is executed. Then end of the case block, end of the module. So this is about case statement. Thank you for watching the video.